17 is the perchlorate ion, ClO4 minus. The process is going to be 7 electrons for chlorine plus 6 times 4 for these 6 per oxygen times 4 oxygens. A -1 charge means add 1 electron. And we're going to get 24 plus 7 is 31 plus 1 is 32 electrons. From there, place your chlorine in the middle, surround it by the oxygens, and that's 2, 4, 6, 8 electrons, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Always put exactly the number of electrons you write down here in your Lewis structure. Then think about next steps. We look at this Lewis structure and we see that all 5 of these atoms have an octet of electrons. That means they each have 8 electrons. From there, we want to do a formal charge analysis. Can anybody tell me for this oxygen what its formal charge will be?
-1.
Thank you. -1. And because all of the oxygens are exactly the same as it, all of the oxygens have -1. Now, can anybody tell me the formal charge on the chlorine?
+2.
+2 is close, but it is a little
+3.
+3. Because chlorine has 7 valence electrons, there are only 4 bonds, so 7 minus 4 is +3.
Oh,
Very good, yeah. Then, and that makes sense because when you do this, you can then say, do my formal charges add up to my charge on the ion? And so -4 plus 3 does equal -1, so that's a good check. Michael was asking about that before, about checks. So that is a lot of formal charge. Our next goal is to do whatever we can to minimize formal charge. And I guess let's do minimize formal charge, FC, by forming double bonds. And I think it's pretty nearly always the case that whatever the charge on the central atom is, so if it can have an expanded octet, you're going to form that many double bonds. So that means we're going to be forming 3 double bonds. There's where one of them will be. There's where the second one will be. And again, it doesn't matter where. How about there? So our next, or our best Lewis structure has 3 double bonds in it, 1 single bond, and since these are Lewis structures, you have to draw all the dots.
Excuse me, Professor.
Yes.
Please, the three double bond that we just formed, is it because of the positive three that is in chlorine?
Yes.
Okay, thank you.
Yep. So when we form those three double bonds, now we can see the chlorine has, so it has 7 valence electrons from the periodic table, and now it has 1, 2, 3, 4, 5, 6, 7 bonds. So now it has a formal charge of 0. That's what I mean by minimize formal charge by forming double bonds. Every single double bond you form from an element with a negative formal charge to between it and something with a positive formal charge takes away the negative and takes away one of the positives. And that's why when I put all my electrons in, right, when we first do the Lewis structure, I sprinkle them around the outside ions because that tends to make them, if it's going to happen, have a negative formal charge. And then I can form double bonds towards the center. There are different ways of doing it. That's just how I do it. Now, we had a choice where we put these double bonds. We could have put the double bonds, one of them down here, and put a single bond someplace else instead. Whenever you have a choice, about where to put the double bonds, that means you have resonance structures. Must draw resonance structures. Can anybody tell me how many resonance structures they think there will be for this ion?
Oh,
There will be 4. Thank you. There will be one resonance structure with a single bond here, as you can already see. One with a single bond here, and all of the others as double bonds. And the way I like to do it is I just sort of rotate the single bond to all the different positions, and then I know that I have my 4 resonance structures. And I imagine the answer key has this, but as you know, it says draw all the resonance structures, so you will have to draw all 4.